Welcome to the final video on separation techniques. So we're going to explore three techniques, or actually two: distillation and fractional distillation, as well as using the separating funnel. So let's explore this question. So if you're stranded on a very sunny island like Singapore, or rather a sunny desert island, which had nothing, surrounded by just the ground and leaves and salty ocean, what would you do to get water? So what we need is pure water rather than seawater or dirty water. Now remember, we're not getting the salt in this case, we want the water. So what would you do? Now, for some of you, you might have thought about this method where you can actually cut the bottle in half, place the ground or seawater inside, and place the top of the bottle on top, and you would realize that if there is enough sunlight and hence enough heat, the water would evaporate here and then it will start condensing at the sides of the cooler part of the bottle and the top. Alternatively, you can also put some leaves here. So you might have thought of using the leaves. You put some leaves here and the water will also condense on the cool leaves and drip downwards. Now, this process will take quite a while, but if you're desperate, this is the best way you can get to get pure water. So, distillation, just to recap, is the process of boiling a mixture or evaporating a mixture containing liquids and condensing the vapor back. Now, the thing that condenses is called the distillate. So not filtrate, but distillate, because it's a liquid that condenses. So distillation as a technique is used to collect liquids, not solids, but liquids, either from a solid liquid mixture, for example, salt water, so to collect water from salt water, or a liquid-liquid mixture, which means, for example, oil and water, and you want to collect water. Similarly, if you have a colored liquid, for example, you have food dye and water, and you want to separate water from the food dye, you can also use distillation. So in the lab, we don't use a primitive water bottle. I think most of you will have seen this before. So you have the apparatus that looks something like this, where you have a thermometer at the side arm, a round bottom flask with boiling chips, as well as a condenser with water going in and out of it to cool the condenser. So this is the setup that you should have seen before. This is just a recap. So in the lab, just to recap, what happens is that the mixture is heated up in the round bottom flask. It starts boiling and it moves upwards. And to prevent the liquid from spurting out, you have boiling chips. So water rises and it will start entering the side of the round bottom flask into the condenser. Now, why do you need a thermometer? A thermometer will measure the boiling point of the substance. So for example, if the boiling point here reads 95, or if the temperature is 95, and you know you want water, you will realize that what is coming out of the condenser will not be water because the boiling point of water is 100 degrees Celsius. So you need a thermometer to tell you what substance is actually being distilled out in this case. So as the vapor enters, because the condenser is cool, the vapor will condense and then you collect the distillate in the beaker or the conical flask. So this is a very important question that they usually ask. Why is it that water goes in at the bottom of the condenser and comes out on the top of the condenser? Why can't it go in this way and come out this way? Now, if you realize, if water goes in from the bottom, this part will be the coolest part of the condenser. And this part will be slightly warmer because all the vapor was passed through the condenser and heated up. But this part will be the coolest where most of the vapor will have condensed already and is moving on to the beaker. So if the water goes in at the bottom, it ensures that this part is the coolest and ensures that any vapor that doesn't condense will definitely condense before leaving the condenser. So this is to ensure that all of the vapor condenses. So let's have a short quiz now on what two processes does distillation involve and what is the purpose of the condenser. Here are your answers. And we are moving on now to fractional distillation. Now this is a form of distillation and it's also used to separate liquids. Now it's not used to separate liquids from a solid liquid mixture. It's usually used to separate liquids from a liquid-liquid mixture. And do take note, the liquids are usually miscible. So miscible liquids, like I mentioned before, are liquids that mix together. Now we'll learn how to separate immiscible liquids later on. So let's take a look at this video that shows the principle behind fractional distillation.
Crude oil is a thick, dark brown liquid found deep in the Earth's crust. It's a mixture of different hydrocarbons, molecules made of hydrogen and carbon. Some molecules in the mixture are very small, just a few atoms joined together. Others are far more complex, with many atoms forming long-chain molecules. But as a mixture, it's useless. The different hydrocarbons need separating. The technique used is distillation. This simple apparatus is set up in a fume cupboard. Mineral wool stops the mixture spitting when it's heated. Crude oil is dropped into the bottom of the tube. A collecting bottle is put in place. And a thermometer level with the sidearm monitors temperature. The final step is to gently heat the mixture by immersing the tube in a hot water bath. The hydrocarbons with lower boiling points begin to vaporise immediately. They're flammable, so it's safer not to heat with a naked flame. As the vapour rises, it enters the sidearm, where it cools and condenses. This happens at about 40 Celsius. The hydrocarbons which boil at this temperature drip down the sidearm and form our first fraction. It's a colourless liquid. The temperature stays at around 40 until all the hydrocarbons with this boiling point have vaporised. The hydrocarbons left behind aren't hot enough to vaporise. Their boiling points must be higher. Once the first fraction has been collected, it's safe to start heating with a Bunsen. As the temperature rises, other hydrocarbons begin to boil. A new fraction is collected at about 60 Celsius. It's slightly yellow in colour. And so the process continues. By carefully heating the oil and collecting the liquids which condense at a number of different temperatures, the many different hydrocarbons in crude oil can be separated. This is known as fractional distillation. On a larger scale, a fractionating column is used. The oil is heated with an electric heater for safety. The vapour is condensed by a Liebig condenser, and is collected in a conical flask. Hot vapour rises up the fractionating column. It's a long way to go, and the further from the heat source, the cooler it gets. Most of the vapour condenses on the glass spiral inside the column and drips back into the mixture. Only the hydrocarbons, which are still vapours at the very top of the column, enter the sidearm and condense to liquid. Industry uses the same process, but on a mammoth scale, in huge fractional distillation columns. The hot oil enters near the bottom, at a temperature of 330 degrees Celsius. The column becomes cooler towards the top. Fractions which remain as vapour at 85 degrees Celsius go straight to the top and are piped away. Different hydrocarbons condense at different temperatures, running off at various levels. Those with lower boiling points are collected at the top. Those with higher boiling points run off nearer the bottom. The longer the molecules, the higher the boiling point. Industrial distillation separates crude oil into useful fractions, each containing molecules of a similar size.
So the idea of fractional distillation is the idea of fractions. So you have a fractionating column that's attached to a round bottom flask. And the only difference between the fractionating column and the normal flask is that the fractionating column contains glass beads that provide a large surface area for the vapor to condense on. Now this allows the vapor to condense a lot more quickly, so it's able to separate liquids with different boiling points. So the fraction with the lower boiling point will be collected first, and another fraction or part of the mixture, the higher boiling point, will be collected later. So take for example that we are trying to separate ethanol and water. So let's say we have water, which I've represented with the purple arrow. It will rise up the fractionating column. And let's say we have ethanol, which I'll represent with the red arrow, which also rises up as it is heated. So it will boil and it will rise up as well. Now, water being the one at the higher boiling point, once it reaches the cool glass beads, it will actually condense back first. Now, it doesn't mean that the ethanol doesn't condense, but more of the water will condense back, and it will return all the way back into the round bottom flask. But ethanol, being the one at the lower boiling point, will actually continue to rise up the fractionating column, or more of the ethanol will rise up, and it will continue rising here until it reaches the top of the fractionating column. So once it reaches there, it's a normal distillation process. It will condense in the condenser, and then it will be collected in the conical flask. So because it is ethanol that it is being distilled, the thermometer should show the boiling point of ethanol, which is 78 degrees Celsius. Now when all the ethanol has been collected, and the receiver in this case, which is the conical flask, then the temperature will rise rapidly to 100 degrees Celsius, which is the boiling point of water. Now at this point, the water will no longer condense back into the round bottom flask, but it will continue into the condenser and be collected thereafter. So this is the point that you need to change the receiver. So once temperature starts rising above 78 degrees, you will change the conical flask so that you can collect a different component of the mixture. This graph is very important. Do take it down in your notes. So this shows the change in temperature as you collect different fractions. So the first fraction will be ethanol. So as ethanol distills, okay, if you remember, a pure substance has a fixed boiling point. So as ethanol continues to distill or boil over, the temperature should remain at 78 degrees Celsius. After there's no more ethanol, the temperature will then rise, and then the temperature will remain constant all the way as water distills. Now let's have a short quiz where fractional distillation is used to separate different parts of crude oil. So which fraction will be distilled over first? And this shows you the answer. Now on to our last separating technique, the separating funnel. Now it's used to separate two immiscible liquids. So immiscible liquids are liquids that do not dissolve in each other. So we do not need to use fractional distillation, though we can, but we don't need to. So usually we use a simpler method called the separating funnel. So usually when you pour a mixture of immiscible liquids into a separating funnel, the denser liquid will be at the bottom of the flask, and that's the denser liquid. And the less dense liquid will float on top. So in this case, oil is the one that is less dense, so it will be on top, and water will be the one that is more dense, so it's at the bottom. So let's watch a video to show you how to use a separating funnel.
In order to carry out an efficient extraction, we must ensure that the organic and aqueous layers are thoroughly mixed. We do this by inverting the funnel. To begin with, you should remove the funnel from the clamp or ring, holding it securely with both hands, and then turn the funnel upside down. When upside down, open the tap to release the pressure that may have built up during the mixing. Then using both hands, invert the funnel 2 to 3 times before opening the tap to release the pressure again. To ensure maximum mixing and maximum separation, you should repeat the process of 2 to 3 inversions followed by the opening of the tap another 5 to 10 times. Then securely attach the separating funnel back in the clamp or ring and watch the layers begin to separate. This separation shows that the dye that we added has gone into the organic phase, which is why the bottom aqueous phase has lost its colour. Now it is time to extract the layers. Always start by removing the stopper from the top of the funnel. Open the tap and drain the first layer into a clean conical flask. Make sure you start to close the tap as the bottom layer drains out to slow the rate of flow and to help you correctly close the tap when you can no longer see the separation between the two layers. Put this conical flask to one side and collect the remaining layer into a new clean conical flask.
So a summary of the video. First, you pour the mixture of oil and water into the separating funnel. And you make sure that this tap at the bottom is closed so it will not start dripping out first. You support it on a retort stand and place a beaker below to collect the liquids. Now, once you pour it in, it will take some time for the oil and water to separate the two different layers. So give it some time, and once you see two clear layers, then you can start the separation process by opening the tap of the funnel to allow the denser liquid, in this case water, to flow down. And just before the water completely flows out, you should close the tap. So now you should only have oil left, and you should switch the beaker. And you open the tap to allow a little bit of the top layer to flow out because you know that maybe there's just a bit of water left. And then you dispose of it, and then you collect the remaining layer, in this case oil, in the beaker. So do complete these questions on distillation as well as the separating funnel before class. And that's the end of the video.